So before we move on to the next few examples in dividing the rational numbers, we need to know something called rationalizing the denominator. Okay, so this is an important concept, and what does that really mean? So before I can talk about that, I'm going to remind you guys to think about our fractions. These are two things I want to talk about, fractions, that I want you to remind. You guys already know about them. One is called equivalent fraction. That means 1 over 2 is the same thing as, let's say, 10 over 20. 1 over 2 parts has the same number. That means half of one part. So if I go make them into two pieces, that's 1 out of 2. But if I take that same number and I make them into 20 pieces, I don't know if that's 20, but 10 of them would represent the same 50%, 50%. So why is that true? How do we go from 1 over 10 to 1 over 20? That means if you were to times both numerator and denominator by 10, you're really multiplying them with the same number. It gives you 10 over 20. So that means 1 over 2 is the same thing as, let's say, 2 over 4, 3 over 6. So as long as your most basic fraction, the most reduced form, is multiplied by the same number by both top and bottom, it will always represent the same percentage. So all of these actually represent the same percentage, 50%, 2 over 4, 3 over 6, 10 over 20. The only difference was that we were multiplying by a different number, but it was same for the numerator and denominator. So that's one. Equivalent fractions is something that we need to remember. The second thing that I want to remind you guys is when we're adding and subtracting fractions, if you have different denominators, you can't add or subtract them like that. So what you have to do is you have to find a common denominator for both of them, and then you convert it into that. So that's a way that you need to be able to find common denominator, and then we use the idea of equivalent fractions again. And only then can you add the numerators. Okay, so one is fractions can be made into equivalent fractions. Second is that in order to add or subtract fractions, we should be able to get a common denominator between them. So that's a very important thing. So if we take that same idea and then think about how does that apply to radical numbers. So if I am trying to add and subtract two radical numbers in which the denominator has a radical number in it, will I be able to use the same idea because they're so basically fractions over here? So I would have to try to make them into the same denominator. But the problem comes here is that root 3 and 2, what kind of common denominator can you get out of root 3 and a whole number 2? They're very different numbers, so obviously that's a problem. So you can't do that. So that's where the whole idea about rationalizing the denominator comes in. They don't want any radicals in the denominator because you will run into problems like this. So if there's ever a radical number in the denominator, how are we supposed to be able to find a common denominator for that? So to fix it, you would have to stop right here. You would have to take your denominator, that number with a denominator of root 3, and rationalize it. Okay, so how do you rationalize a denominator? Okay, we're going to use this idea of equivalent fractions. It's a very simple thing. Just multiply both the top and the bottom with the radical part of it. So the root part here is root 3. So just multiply both of them with the same number. If you do that, we know that's equivalent fractions and it will represent the same thing. So you're not doing anything wrong. 1 times root 3 is root 3. But this is what magic happens here. Root 3 times root 3 becomes root 9, which is exactly what we want because that creates a perfect square and it'll in turn become just 3. We don't care about what happened to the numerator. We wanted to rationalize the denominator. That was the problem. The denominator now went from root 3 to just a 3. Yes, I complicated my numerator, but that's okay. That is not something we're going to be concerned with. We just simply don't want the denominator ever to be a radical number. So whenever you have a radical number in the denominator, we rationalize it by multiplying it by the radical part of it right there. So whatever the radical number is in the denominator, multiply both numerator and denominator with it, work it out, and you will have a fraction with no radicals in the denominator guaranteed.